Charlie, welcome back to Talk Python to me. How you doing?
I'm good. Thanks so much for having me back. It's always a pleasure to be on here.
Well, you are certainly making waves in the Python space these days with all of your projects and their fastness. I think you're known as the fast Python guy these days. Like, oh, that's not fast enough. We got to use something from Astral.
The fast Python tooling guy, maybe. Yeah.
Yeah, exactly. Exactly. So interesting. We spoke, I think you've been on twice before. Is that right? We talked about
I think so.
Rough
Yeah.
once.
I came on once to talk about Rough, and then I came on in March shortly after we did the first public release of UV.
Right. And UV at that time, I'll let you tell people what UV is, but for those who know, it was kind of it has pip-like features. And now it's got another layer to the onion, or another shell to it. And that's actually why I invited you back, because there's a lot of interesting things to talk about there.
Yeah. Maybe like several more layers too, I think.
Okay, well. All right, well, let's hear about them. So first of all, I guess, not everyone, believe it or not everyone listened to that first Rough interview and things, RUFF interview, and those kind of things. So I suppose maybe quick introductions to you, to Astral. How'd you get to where you are?
Totally. Yeah. So, I've been working on Python tooling full time for a little under 2 years at this point. And my journey, I've been writing Python professionally for a long time. But my journey with Python tooling started with Rough, which is a very fast Python linter, code formatter, and code transformation tool. And what's the sort of foundational idea of Rough was, can we make really fast Python tooling? And so Rough is written in Rust, but you don't need to have Rust installed or know anything about Rust to use it. You can just install it with pip or with whatever you're using. And that whole sort of story for me started from just working with Python a lot and asking if we could build sort of different Python tooling by using languages like Rust. So, the first version of Rough was very minimal, but it's grown from then to have, we have something like 800 plus rules. If you've used tools like Flake8 or Pylint in the past, Rough can do similar things. So discover issues with your code without running it. It can also fix them automatically. And then if you've used tools like Black in the past for code formatting, Rough can do a similar thing too, where it automatically formats your code. Yeah. So that was how I first got started in Python tooling, and also how I first ended up on Talk Python. Was people were very interested in this when it came out, and
I think it broke a lot of people's minds in the sense that it really changed what was possible. Some maybe an analogy. So if you have unit tests, but to run the unit test takes 30 minutes, there's no one who doesn't just want to kill time who's going to say, I made a small change, let me run the test and see how that change did. But if the test run in 50 milliseconds, you could just set up a thing to just run the test every time code changes and just have a green red light, right? And I feel like Rough did that for linting and formatting. Like for me, for example, I have it just run Rough on. If I use PyCharm, ask PyCharm to reformat the code. It uses Rough to do that. And you can check the box to just say, run it when I hit save, because you won't notice a difference. You know what I mean?
Yeah. I think that's been one of the really interesting things about working on tooling with the focus on performance has been, like, if you build things that are way, way faster than what currently exists, like not just like a little bit, but like significantly faster, the ergonomics of the tool just change a lot. So maybe things that you only ran in CI before, you can now run locally, and maybe things that you now run locally, you can run on save, as opposed to on commit or on explicit command. So that's been a big part of what we've seen with Rough. And the other big piece, apart from performance, that I think we sort of accidentally made a lot of progress on with Rough was just trying to make things simpler by bundling more stuff together. So Rough
Yeah.
can do like a lot of different things. And so you don't need as many to chain together as many tools to get the kind of setup that you might want to have in your Python projects. And so,
Yeah.
a lot of the things we built, with Rough and with UV, they've had these kind of dual goals of, being much faster, hopefully bringing in some interesting new features and functionality, but also trying to reduce a little bit of the, the fragmentation and the tooling and make it easier for people, especially, for newcomers who are writing Python for the first time, to kind of get started.
And you have announcements. I have things to discuss with you about them, about making that even easier. So that's why some of the big features of UV, right? For example, what if I don't have Python? Not a problem. So that's pretty exciting, I think.
Yep.
Yeah, and we'll get into that. But I do want to just not get too far past it, because even though this episode is not about Rough, two things. One, a theme of Astrals is we're going to take some tools or some kind of concept that's been around for a long time, redo it in Rust, but also not just, we ported over the code, but rethink some of the algorithms and some of the assumptions. And I think that's also a lot of what makes it faster, like the way UV works with caching and things like that.
Yep.
And there's been a lot of excitement and positivity about that, but I think there's also been a little suspicion of, well, wait a minute, if we write this in Rust, is it really for Python people, by Python people? Like, what's your take? I have some thoughts that are, I don't see it as a negative, but I think it's interesting just to discuss, where does Rust actually belong here?
Yeah, I mean, I think like the way I view it is that, just like Python itself is implemented in C, like it makes some sense for like the underlying tooling that people are using to be written in a different language, if it means that you can ultimately build, tools that are better, at least on some metrics that people care about. So like for me, I sometimes view what we're doing as, like we put all this investment into this tooling, we write all this stuff in Rust, which, in theory incurs some cost for us. It's maybe, maybe we move a little bit more slowly, maybe it's harder. And in doing so, we kind of like give all these people who are running these commands, hundreds of times a day, a big boost in how they work. And they can keep writing Python, but have a better and better experience writing Python. So, I don't think it actually really says anything personally. I don't really think it says anything about Python that we write the tooling in Rust. Because, we get, sometimes people will criticize Python for that, but like, different languages are useful and good for different things. And Python is an incredibly productive language. It's like growing more and more every year. People love writing it. But maybe it's not the best language to write, a super high performance package manager. And that's totally fine, because like we're going to do that. And then everyone who's writing Python can benefit from it and can leverage it. I do think that one interesting piece here that I got, we got a lot of skepticism around early on was like, how can people in the Python community like contribute to this if it's not written in Python? How do you like have a sustainable contributor base? And the interesting thing for me is like, I actually think we've had a really strong contributor base over time. Like we have, I don't know, like somewhere between 400 and 500 contributors total, maybe in Rough. Most of those are like one or two small, one or two commits, maybe just one or two time committers. But a lot of people have come to Rough and said, I want to learn Rust. I come from the Python ecosystem. There's a part of this that's sort of native to what I know, which is the Python language, the Python semantics, and it's an entry point for me to learn Rust, from other people who come from Python. So, I think there is certainly a cost to engaging and a cost for contributors, because most of our users don't know Rust. But I don't think it's as steep as people would expect. And I think, over time, we have been able to grow a pretty healthy contributor base, like of many people who've never written Rust before.
Yeah, I agree. And I was thinking the same thing that you pointed out, that Python itself is written in C.
Right.
Generally speaking, of course, there's multiple runtimes and so on and so on. But C Python, the one that we generally use, is written in C. And I mean, I don't see why there should be an allegiance to C over Rust or anything. And a lot of the data science tools are written in C or Fortran, even, something
Right,
really
right.
wild like that.
And Python is a
And
way to kind of expose them and make them more accessible, more useful, make people more productive on top of those that's a native code.
yeah, yeah. A third example would be Jupyter, Jupyter Lab, Jupyter Notebook, all those things. When you talk to the contributors of those projects, they're down in TypeScript and
Right.
JavaScript most of their day. So the data science folks don't have to write TypeScript and JavaScript. They just work in the tooling that's on the front end. And so it's, it's kind of like, to me, it's kind of like, let's take one for the team.
Yeah.
We'll do this. So we all benefit, but you don't have to. You don't have to do it.
I actually think it's one of the kind of one of the real strengths of Python is the interoperability around like native code and extension modules. It's actually like a big part of Python, and it's a big part of why Python has succeeded. And I think that will actually become more, I mean, this is sort of like going off on a tangent a little bit, but I think that will become a bigger and bigger part of like what Python looks like and what it looks like to work with Python. Because, and I think Rust can actually play an interesting role here because, at least from my perspective, like I do not have a systems programming background. Like I've definitely not written any C professionally. I don't think I've ever really written any C++. And Rust was my first sort of foray into that kind of programming. And I think, at least me, for me personally, I found it much more accessible. And so I think Rust and Python actually have this interesting story where Rust, to some degree, is this kind of like superpower low-level layer that you can drop into and then expose with a Python CLI for everyone to consume. So anyway, my prediction is I think that will only become more and more of a part of what Python looks like. And that's actually, I think it's actually a good thing.
Yeah, I do too. Jake out in the audience, Jake Callahan, who says in another comment, great timing. I just released a video on these changes yesterday, so that's awesome. But said the progress made in Rough and UV since their introductions clearly demonstrates that there's a strong contributor base, even when it's based on Rust, right?
Yeah. Yeah.
I think
I'm not trying to dismiss that it's hard to learn Rust, because I actually think it is pretty hard to learn Rust. And I think the learning curve is pretty steep. But I think the thing we found is there are people who are interested and who want to do it.
Sure. I agreed. I think another thing that it shows, regardless of Rust or not, is if it's your full-time job and there's funding and a team rather than part-time work, it can go many times faster towards a goal than before. I'm sure you've felt that way.
Yeah, I mean, we're in a very unique, I mean, not completely unique, but fairly unique position whereby we can fund people full-time to work on this stuff. And it's actually just kind of wild to look at how much, not to sort of talk up our own work, but just how much you can accomplish in a relatively short period of time with that level of, when people are kind of unlocked to work in that way and work on those kinds of problems. So, just thinking, it's like the amount of time we've been able to put into Rough and UV is like sort of hard to fathom for some open source projects. It's like, wow, that's incredible. But from the perspective of a company, it's actually like quite reasonable. And in fact, not even like that much. So, I think it's pretty, like the leverage that you have with open source, like when people are able to invest in it and really focus on it is pretty amazing. Because, we work on these things, we improve these things, and they ship out to, I don't know, millions of users or whatever it is, and really can provide a huge boost to the ecosystem. So yeah, I mean, being able to work on this stuff full time, that was actually something that I decided pretty early on with Rough. Was the project was growing more and more popular, and I was like, I don't know if I can keep up with this if I don't work on it full time. And so I'm at least going to see where that goes. And if it's possible.
It's possible, right? And here you are.
I mean, it is, but yeah, it's like, I mean, I just feel like I just have a lot of respect for people who, commit significant amounts of their time to open source alongside everything else. Because it's an amazing thing, but it's also very challenging. And
it definitely is.
it's 24/7.
Well, I think it's really positive that there's a group of people putting their full effort into, especially the UV side of things. That's gonna make a dent.
Yeah, I mean, I think the other thing that's been cool about building this as a company is that we've been able to bring in a lot of people from like outside of Python to come and work on Python tooling. And I think that's like a really healthy thing for the ecosystem, because not only are these people, I think like really talented and really great, but they also bring like very different ideas and experiences. And so we have a lot of cross-pollination on the team. The team's kind of a mix of people who fall everywhere on the spectrum of like, or axes, I guess, probably not the spectrum of like how much Rust experience, how much Python experience they have. Some of them have mostly worked in like TypeScript and the JavaScript ecosystem. So that was sort of an intentional thing for me when thinking about like building a team to work on this stuff. Was I want to have like some people on the team who are like super deep Python experts, and I want to have some people who like bring a totally different perspective to the problems. So that's been another like very cool piece of putting together a team to work on this stuff.
I think that's a great perspective. All right, one thing before we move on to talk about UV proper, closing the loop here, is you mentioned those rules, those 800 lint rules, and this resource you have over at docs.astral.sh/rough/rules is awesome. So even if you don't use rough, you care about, say, PEP 8 naming or something, you get a warning from Flake8 or whatever, and it says under function name. Like, what is this error, right? What is this thing? And then you've got each one of these rules has a, what is this? Why is it bad? How should you change it? Here's the bad version. Here's the good version. And so on. And I think this is just a really good resource. I know you all put a ton of time.
I appreciate you calling that out. Yeah, it takes a lot of time. I mean, once you cover all the rules, maintaining it incrementally is slightly easier. But when we started this, we definitely had a few hundred rules, and so we, it was a lot of contributors who contributed us getting to full coverage here.
It's almost like the Wikipedia of lint rules or something.
How to Python, yeah. I guess maybe one thing I'll say is like we have a lot of rules, but you don't have to use them all. And like the default rule set is actually pretty small. So even when I work on projects, I don't necessarily enable all of the rules. I typically enable like a couple subsets. So I just think sometimes it can be intimidating to imagine 800 rules being applied over your code base. So, the default rule set is pretty small. It covers things like unused imports, things that are pretty common and relatively unobjectionable. And then we have all these different categories for ways that you can kind of level up the level of coverage.
Yeah. I take pretty much the defaults as well on all my projects, except for wider lines of code, more columns.
Yeah.
Because
on
a 32-inch monitor, 80 columns is just down the little corner.
We actually took that out of the defaults.
Did you? Oh, beautiful.
Yeah.
So I don't need a rough.toml or whatever it was I was putting in there for configuration.
Yeah, we got rid of that because the thinking there is like, if you have long lines, they should generally be handled by a formatter, not a linter. Yeah. So by default, we don't enforce that. Yeah.
Okay. Interesting. And then the single quotes versus double quotes, which we discussed on GitHub. I remember. I think we talked about last time.
Yeah, probably
as well. Yeah. And
I talked about that with everyone.
Yeah. And Miguel also agrees here. Amazing docs. The rules are top notch. Nice work.
I appreciate that.
Okay. So I know we're going to talk UV, but Tushar does have a good question out there. And I don't know if speak to it or don't speak to it. Are there plans for Rough to become a Pylance alternative? So a language server of some sort. Is this anything that you're willing to talk about?
I mean, yeah, I think that's like an interesting thing that we'll consider. It's not something that we are committed to doing or committed not to doing, like building a language server. I would say that's probably like a few steps away from where we are today, because before we would build a language server, we would probably build, something like a type checker, like something that could deal with type inference and like better understand the relationships between different parts of your code. I view that as like, it's not strictly a prerequisite to building a language server, but I view that as like a little bit more of a path.
More MyPy
Yeah,
type
more
of deal?
MyPy. I think there's like a lot of interesting stuff around building a. Well, first of all, of course, there's like building a type checker, but there's also building what I would call like a type-aware linter. Like you could imagine that Rough itself could actually get a lot more powerful if it could do all sorts of type inference. Like we have some rules that are only supposed to activate on dictionaries, and we do some sort of bad local type inference and heuristics to figure out if we think a variable is a dictionary. Like if you call .get on it, it might be a dictionary, right? So if we knew, there's just a lot of interesting things we could do. We could build a much better tool. So it's not just about building a type checker. It's also about how can we build a much better linter and sort of like set of tools. But yeah, we're thinking about that a lot. There's a lot of discussion happening about that, both internally and publicly. On the repo and the Discord. We're thinking a lot about sort of type inference and how to evolve Rough in that direction. So yeah, language server may be something we could do eventually. It's obviously a huge undertaking. And we want to make sure that like anything we decide to build, we feel a lot of conviction, that it can be great, because doesn't necessarily make sense for us to try and build something that we think is like 5% better than what's out there. It's very hard to get users to switch to something that's 5% better. So, when we look at the opportunity set, we're kind of thinking about where can we have a big impact? What do users really want? Cross-referenced against where do we think there's opportunity to build something that would be an improvement in ways that users care about? So yeah, very interesting. Not something we're focused on right now, the language server piece at least.
Yeah. So you guys are going to need at least a few weeks to get to that, huh?
We're going to need a few weeks to get to language server. Yeah.
All right. Ivan out there in the audience says, excellent tool. Rough and UV have changed my life. We've talked about Rough.
That's very nice.
Yeah. UV, maybe a quick summary for what it is, and then we could talk about your post, which adds layers of features and capabilities as we
totally
said at the start.
So I came on the show back in March, and we talked a bit about what UV was at the time. We released UV in like mid-February, so that was a couple weeks after. And UV is our Python packaging tool, and it's built in under a lot of the same sort of design goals as we had for Rough. So we wanted it to be extremely fast. We wanted it to try and bundle a few more things together so that you could use fewer tools to work with Python and be productive with Python. And we wanted it to be really easy to adopt. That was another principle that we've thought about a lot. So when we released UV in February, it was framed as a pip alternative. So the idea was if you've used pip before, pip install, pip uninstall, or tools like pip compile or pip sync, it should be really familiar to you. So the API that we started with was like UV pip install, UV pip uninstall, UV pip compile. And it was meant to kind of mirror the pip API. And the idea there was we wanted it to hopefully be immediately obvious to people, like how this tool works and what it does, and also, I guess, to some degree, what it doesn't do. So we released that in February, and it grew extremely fast. It's just the adoption, both in terms of like raw numbers and just like the companies that we talk to that are using it, like very quickly, a lot of people were using it. I consider it a big success. I'm really happy with how that went. But it was also like, I think a pretty small, it was sort of a small portion of like what we wanted to build for packaging. Ultimately we weren't trying to build just a faster pip. I think that's like I think it's a really good starting point for a couple of reasons. One, much easier for people to adopt. Two, it required us to build a lot of the like fundamental pieces that you need for Python packaging. Like in order to build a pip alternative, we had to be able to resolve Python dependencies, like install Python packages, understand virtual environments, right? Manipulate all those things. We had to implement a bunch of standards around introspecting built distributions and source distributions and virtual environments. So we had to invest in all these things that are like fundamental, that I view as kind of like fundamental primitives of working with Python packaging. But the ultimate goal for us was always, we want to build something that's like a single static binary that you download and install that just gives you everything you need to be productive with Python. And from that perspective, like a pip alternative it's pretty low level. And we wanted to build something that was a little bit more high level, something that can install Python for you, something that can manage the virtual environment for you, something where you just do run this file and it figures out the dependencies, installs them, it creates the environments, and it runs this file in the environment. Like that is what we wanted to build. So that's what we've been building up to over the past couple of months.
Yeah, amazing. Of course, you've got to have the UV pip features as a foundation, right? Because
Right.
even if you don't, kind of like we talked earlier, even if you don't expose it directly as a CLI thing, that from a project management perspective, it's needed, right?
Yeah, and like it's part of kind of like meeting people where they are to a certain degree. Like everyone has workflows that are built around pip. Like even people that do that have other packaging workflows, often those workflows are actually built around pip commands. And like I said, I view those as a little bit low level. Like with pip, the operations are kind of like install this package into this environment, as opposed to here are my dependencies, make sure the world is like in sync with my dependencies. That's what I would consider to be like a little bit more high level. So, we built and released that pip interface in February. And since then we've, it's basically been like hammered, right, by users. So it's just gotten like better and better, right? Because they find problems with it and then report them, and it just gets, it gets better, it gets faster, it gets like more feature complete. So we've got a few months to kind of improve it and build on top of it too.
Yeah, that's one of the benefits of it taking hold so much and people using it so much is they hit the little edge cases all the time, and
yeah, a lot of edge cases.
Smooth out quick. Yeah, I bet.
Yeah. But it's super fun, like set of problems to work on, by the way, and like really different from Rough too. Like, Rough is more like it's more like a compiler, I would say. Like we have like a parser, an Alexer, all that kind of stuff. And with UV, it's a lot more, how do we do IO really fast? Like we have a lot of networking. We're like reading and writing from disk a lot. There's a lot of interfacing with standards, a lot of interfacing with the registry. Everything's async. So it's just like a very different set of problems. And it's fun to get to kind of work on both of them because they're just really different.
Yeah, I'm sure they're both fun projects. And there's some really good ideas and questions in the audience, but we're not ready for them. So I think when we spoke back in March, one of the things we discussed is how you structured the CLI API in a way to leave space. So for example, it's not UV install package, it's UV pip install package. And it's not UV compile -- update for dependence. It's UV pip compile or whatever the command is, right? I have it aliased to a couple of letters and I never think about it again. But something, that's you've left space in the CLI with these subcommands. And I think now we're starting to see why you left space. Is that right?
Yeah, that was like pretty controversial at the time and users really hated it. I mean, they still used it, but like
it's so much better. I'll use it.
A lot of people complained about it. I even found myself saying like, maybe we should stop doing this. Like maybe we should just give up because like people were complaining and like I was annoyed by it and stuff. But yeah, it's either like a huge, obviously, like it's either like a terrible mistake or it was genius. I don't actually know, but but what it did was, right, like one effect, which I said before, was it immediately conveyed the sort of rough shape of the commands, like UV pip install. And then if you've used pip install, you know that the next argument is like a package name or a requirements file. But the other thing it did is it left space in the CLI for these new APIs that are sort of first class UV APIs. So instead of doing UV install when we released in February, it was UV pip install, which meant that today, this new set of APIs that we launched, 2 weeks ago, I think today.
Scroll up, is there a date? There you go, August 20th.
So this new set of APIs that we released are, UV lock, UV sync, UV run. They can all be top level because they're really like the first class UV workflows. The pip API, by the way, still 100% there, and like we're gonna invest in it a lot and like continue maintaining it because like that is how most people use UV. And maybe eventually we want that to be less true, right? Like we hope more people use the new stuff. But like we're gonna keep building that. But for projects that can, we now have this new interface that if you can fit into it, it's just sort of more powerful and does more for you. So we saved space in the CLI exactly for this reason, which is we had a bunch of stuff we knew we wanted to build. And if we polluted, well, not polluted is the wrong word, but if we polluted, the interface with UV install,
Clogged. If you clogged it up.
Yeah, if we lost all that space to those existing commands, it would make things harder. So I think it's worked. It's had the intended effect for us of it kept the space open, it let people use it, it conveyed how it works. And now they kind of exist alongside each other. And the pip API, you can kind of use them together in certain ways. And when you use them together, you sort of realize that the pip API is more low level. It's like the new APIs, you have a PyProject TOML file with your requirements in it, and you just run UV sync, and it will resolve them, create a lock file, install them in a virtual environment. That's like one command. You could then modify the virtual environment. You could do UV pip install, blah, 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 and start making edits to it. But that kind of illustrates what I mean by it's like a low level pip APIs where you're kind of manually manipulating things versus these higher level APIs where you tell us what your dependencies are, and then we figure everything out for you.
Yeah, that's excellent. Just one comment on it's too many words or it's too long or whatever. Like I hinted at before, I just have aliases for these. So for example, I just type PIR, and that means UV pip install -r requirements.txt. And I don't care if it's UV pip that or it's pip install dash, whatever. I don't want to type any of those. So it's just PIR. Let's go.
Yeah.
And I've got 3 or 4 of those, one to make virtual environments with UV and a couple of things like that, and one to compile the changes. And, you look up, for me, I look up the docs. I go, okay, well, here's how I'm going to shorten that to something I never think about again. So it doesn't matter.
Yeah, that's totally fine, right? That's totally fine.
But you do got to consider, I guess, the workflow for new people. And maybe that's a good place to talk about the features here. So one of the things that really there's a lot here. One of the things that, even though it's number 3 on the list of 4 things, is the Python command. So UV Python install, UV Python list, all of those kinds of things. I mean, maybe we should start there, because without that, we don't have any Python. Although
so
that runs sort of implicitly under some circumstances, right?
Correct. Yeah.
Okay.
So part of what we wanted to do with this release was make UV sort of self-bootstrapping, which sounds complicated, but the idea there is if you don't have Python installed, UV doesn't depend on Python. It's just a binary. So you download it, and then when you run a command like UVVM and you give us a Python version, if you don't have any Python installed, if you don't have that version installed, we will download and install it for you. So you can sort of seamlessly run these commands without worrying about how do I install Python, where is my Python, et cetera, which means that we can achieve this really cool experience where the whole set of commands you need to create a Python application are you curl install UV, and then you just run UV init -- Python, and we create a project for you. We download and install that version of Python. You can just start running things. You don't have to think about how do I install Python? How do I get it on my machine? Do I have the versions I need? Anything like that. So you can obviously turn this stuff off, right? And you can use your own, it'll also respect Pythons that you have on your machine already. But part of the goal was we wanted to get to this, I won't call it the holy grail, but this experience of you just download the binary, you do UV run, and everything just works. And so that was a big part of it. And if you look at the full list of things that we put in this release, there's kind of a lot of stuff, right? There's 4 bullets of things that each of those could be a big release. One is the Python installation. One is we have this sort of tool install, kind of like pipex. So if you want to install Rough globally, you can do UV tool install Rough. And we'll install it for you. It'll get put in your path, everything like that. We have these project management APIs that I've hinted at a little bit throughout this conversation, like UV run, UV lock, UV sync.
We'll get into it.
And we have this thing around script execution. So, I thought for a long time, that these would actually all be separate releases, that we would do a staggered series of releases. And I was excited about that because, well, first of all, that's always fun. Like you kind of like have a bunch of things and you're like shipping like 1 week, and everyone's like, oh my gosh, we're shipping so much stuff. But the thing we found was like they're all kind of interconnected in subtle ways. And like the project management and the tool API, they're just not as interesting if you don't have like the Python API. Like they are interesting, but the fact that we have the complete story of like you do UV run and we install Python, we resolve your dependencies, we install your dependencies, we run the command in the environment, like that whole picture, like everything's a little bit interconnected. So that's how this release came to be so much stuff, is we had this vision for what we wanted the full stories to be, and they all became somewhat interconnected. And you know, in the end, they're all like individually, I think, really powerful things. But they kind of come together to give this what we want this Python experience to be. And we're not like totally there yet. You know, we're missing stuff for sure. But this was our attempt to capture kind of a couple different workflows that are intertwined in different ways.
Yeah, I see how they all interconnect, but they are also interesting on their own, right?
Yes.
The Python installation thing
And
is interesting.
usable on their own, by the way.
Yeah,
So,
yeah,
like,
exactly. They're all independently used. Like, if you just had one of those, you'd be like, "That's pretty cool." Okay, I like that. That's pretty cool. So let's talk just a bit more about the Python one. So there's analogies here to other tools that people may know, and the closest one for this would be PyEnv. Do you think?
Yeah, probably. It's like there are obviously differences, but that's a very popular one that most, you know, a lot of people know.
Yeah. I'm not saying they're identical, but it's fulfills a role that a lot of people were solving with it. Now, when I tried to do PyEnv, I don't remember what I was doing wrong, but this was the early days of Apple Silicon, and maybe I had the Intel x64 version of Homebrew, but I had the build tools for ARM. I can't remember, but I could not get it.
Rosetta or something.
Yeah, and I couldn't get it to install anything with PyEnv because it would download it, it would try to compile it, then there'd be some weird compiler bug, and I'm like, you know what? I'm not debugging the source of I'm just not debugging this. I'm out. I'm just gonna go download it. And also that's I compile Python for some of the server stuff I'm doing, and it takes a while. It's not that fast. And when I get it from you guys, if I say UV Python install 3.12 or something, boom, I get it. Like in your standard style, it's fast. How is it fast?
Yeah, so that comes down to like sort of a fundamental difference between what we're doing and what I don't know if it's PyEnv or PyEnv, by the way.
I think it's PyEnv, by the way.
Okay, so I'm just going to say that because
let's go with that.
If I try to do the other, I will mess up. So like the way that PyEnv typically works is, it's a great tool. A lot of people use it. It's building Python from source. And there are trade-offs around this, but the idea is it will build the version of Python that you need. What we're doing is we're building atop a project called Python Build Standalone by originally created by Greg Sork. And that's a project that we've started contributing to. So I think I did the last 2 releases maybe. But the idea here is we have these standalone, easily redistributable Python builds. And when we do a release, it will create Python builds for a bunch of Linux architectures, for Mac OS, for Windows, on all the different Python versions. And it will also run a bunch of optimizations over them. So it'll do, it's not these acronyms, it's not important that you understand them, but it can do like link time optimization or LTO and profile guided optimization, PGO. So we build all the binaries.
That's pretty impressive.
Yeah, we do. That all happens in advance. So if you go to like the releases page here, like scroll up a little bit, and just click their latest release on the right. Yeah, you'll see like all the like 773 artifacts. That's like 773 Python builds. So it's a lot of different Pythons. Yeah, it's like a lot.
773 different.
Yeah. So like we build all this stuff, and then when you run Python install, we figure out the correct. See, we have like ARM, we have like all this stuff. So then we figure out the correct Python for your machine. We just download and unzip it.
And the same way you get a wheel is the way you get this.
Yeah, I mean it's actually the same code pretty much like under the hood for us, right? It's like we stream and unzip it down into disk. And that's great. It's like super fast. It's also, they're already optimized like PyEnv by default does not compile with optimizations. You can compile with optimizations, but it's not what it does by default. So these will be, noticeably faster than what you would get by default with PyEnv. There are some downsides. Like some people like to build from source, right? They like to have like effectively the full chain of like reproducibility in the build, and now you're kind of trusting us to give you your Pythons. So that is a downside to some people.
Yeah, but then the next thing you do is you pip install something that has a binary wheel anyway. So
yeah, no, that is true. There are also like a couple quirks with these builds that we're working on a little bit. Some of it has to do with like licensing, the fact that you want to have kind of a you want to have a self-contained Python, and there are some things in there that require licensing changes. So it uses there are some slight deviations from what you would get with building from source from CPython, and those are documented in Python build standalone. But the general idea is we pre-build and pre-optimize these Pythons, and then we download them on demand, and it makes it really fast.
Awesome. When I go to python.org and download a DMG package or an MSI for Windows or whatever, it runs this installer process that takes a good long while. And, Jake just pointed out similar experience I had. It says it took me less than 2 seconds to install 310. And
Yeah.
I think same thing for 312. So are we missing anything compared to running a proper installer that seems to take 20 seconds, even on a fast computer?
I think those installers also have to do some operations from source, most likely, because they're not shipping. I could be wrong about that. I haven't looked at them closely, but Python in general, Python.org does not distribute these kind of pre-built binary distributions for all these different architectures. And there's interest in doing that, and I'm also interested in doing that. But it needs to be, there are some things that need to be decided, standards that potentially need to be set. So it's possible that eventually we can just grab these basically from python.org. I think our PyPy downloads come from python.org, if I'm not mistaken. PyPy, that is.
Yeah.
Or it actually might come from pypy.org. No, I can't remember. Okay, anyway. Those come from some sort of official source. Yeah. So
okay.
Yeah, maybe eventually. But for now, we're using Python build standalone, and we've just been trying to grow our familiarity with the project too.
Right. Okay, so let's give people a sense here. Like, they do not have Python at all, or they can't count on having Python or the right version of Python. They can run a single shell command to get UV, which UV can then manage itself. They could pip X install the UV. Can you homebrew?
Yeah.
What other way?
You can get UV on your machine however you want. UV doesn't need to be in the virtual environment that it's manipulating. It can just be anywhere on your machine, and it can operate on any environment.
External tool sort of deal.
Yeah. So you can install it with pip. We have our own standalone installers that you can curl. It's on Homebrew, right? It's on you can install with pipx. You can install however you want. And then ultimately it can operate on any environment on your machine. So I actually don't recommend installing it in a virtual environment. I recommend installing it globally.
That's how I have it as well.
Working from there. Yeah.
I believe I've pipx installed it, because anything that falls into that category for me goes under pipx, at least for now.
Yeah.
We'll
there's one interesting thing is if you use our installers, like the curl installers, then you get access to self updates. So you can run UV self update, and we will update to the latest version.
That's right.
We can't really do that if you, you can't do that if you installed through a different package manager, because we don't really know how it was installed. So if you install it through the installer, right, we write a receipt that we understand where we installed it and all that kind of stuff. So that's one benefit. But it's not, you're not required to do that, of course.
Sure. I ran into that when I just wanted to see what it would do when I ran a self-update. And it said, you install this from a package manager type thing, so go do that thing. But that's fine. I have automation for all those things, so it's not a big deal and so on. So to give people a sense, once UV is on your system and in the path, you can say UV -v Python and put some variation of a Python version And if you have it, great, it'll use it, right, to create the virtual environment. If you don't have it, it will then do this 2-second download install deal, assuming you have fiber, and then create a virtual environment based on it, right?
Yep, that's right. And you can turn that off, but that is the default behavior.
Yeah, it's awesome. And then you can also pass commands like managed only, I think it is, or something like that, where you say, don't use the system Python even if
Yeah,
it
yeah.
exists.
Only
Like,
use
if
the
you don't,
Pythons that UV will install, or like only
exactly,
use the Pythons that are on my machine. Ignore UV's Pythons. There's some customizations around that.
right? Like you could do
Um,
the opposite.
I will
One
also
benefit of
say
that, yeah, go
this
ahead.
version, by the way, this version format request thing is like
Is it
so
gnarly?
hard. Yeah, it's just like you just be shocked like how much engineering work has gone into like understanding those requests and then discovering all the Pythons on your machine. And
Yeah,
the discovering
yeah.
all the Pythons on your machine problem, by the way, is a problem that like a bunch of tools have had to solve. And we've talked with like, you know, like the VS Code team about
Mhm.
fast Python discovery, because there's just like so many different places that they could be. And like on Windows, it's also like totally different than on Unix. So anyway, a lot of work has gone into that. But it's kind of like hilariously flexible now. That you
Mhm.
can say, yeah, you can say CPython greater than or equal to 3.12, right? And then we'll look for CPython rather than PyPy or rather than GrailPy or
Yeah,
whatever. So
yeah.
anyway, a lot of work went into that.
What if I just say UV, VE, and I have no Python whatsoever?
I think we would install the latest Python.
Would you just go, yeah, just do a latest, like
Yeah.
maybe
I
an
think that would count
implicit
as
dash
any
Python space 3?
Yeah.
Yeah.
I think that would count as give me any Python from
Mhm.
the list of downloads, and then we sort by version. So I think you would effectively get the latest compatible version. But now
Yeah.
you're kind of quizzing me a little bit. So
No,
might be
I don't mean to be quizzing you.
No, I'm just kidding.
All right, so we'll move on. I know there's so much more, and we don't have a ton of time to get it, but I just pulled up my Warp terminal and I typed UV Python list, and it shows me a bunch of options for ARM64 for macOS, 3.12.5, 3.12.0, 3.11.9, 3.10, 3.8, and so on that I could pick. However, I'm just wondering where your cutting edge needle or setting is going to go here.
Yeah.
I don't see a 3 of 13.
Yeah,
There's
we're working
a
on
release
it.
candidate.
We're working on it.
And one of the
I
things
know.
that is tricky about any of these package manager stories is if I homebrew it, I'll see that there's a new Python, especially a major release, but I might have to wait a week before it's available on homebrew. But homebrew will auto update it. But if I install it from the installer from python.org, it won't auto update it. And there's always a little drawback of it.
Yeah.
And so when I saw this feature, I'm like, well, if this thing could just really soon have the newest one, that would just be icing on the cake. And so what is your policy on how quickly to adopt new things, how quickly to adopt release candidates and betas and things like that?
Yeah, like with 3.13, I mean, I would like to have it out as soon as there's an RC. That's what I would like to do.
Okay.
Our policy or our goal is to make sure that it's out before the stable release. So we would like to not be lagging on the stable release. And we view like the minor releases in Python similarly in Rough historically. Like we'll be like, okay, we want to make sure that we support all the 3.12 language features before 3.12 is stable. And there were like a bunch of language features in 3.12. There was like some new grammar, there were new typing features. And so the goal there again was like, the goal is to have it out by the time it's stable. So that's typically like the contract we try and uphold. And that's still our plan for 3.13.
Okay, awesome. Yeah, good to know.
Yeah.
Jay Geller says it would be nice to have an option to install pre-release build. And Tushar says the thing is, Python build standalone builds 600 releases per version number. Having that run daily is too much. But if anyone could do some interesting caching, surely the Astral folks could do.
It's kind of amazing though. That project runs. It's not we don't own it. It's not under our org.
Yeah.
That project runs completely for free on GitHub Actions.
Wow. GitHub's
Isn't that
kind
just
of crazy, isn't
remarkable?
it? Yeah, GitHub is ridiculous.
Yeah. So anyway, that's
How
kind
much
of
traffic it
pretty cool.
handles, and how
Yeah.
much data. Yeah, they're pretty awesome. Okay, so
Yep.
if you don't have Python, you can also, you don't have to do a V. You can just say UV Python install, give it a version,
Mhm.
and you'll just have that. Like that's what Jake and I were referring to earlier. But you can also create a V, and this is sort of a philosophy that I'm getting. And sorry, someone said this earlier, but it scrolled off the live stream comments that this prefer or require virtual environments by default rather than prefer to try to jam stuff into system Python or the core Python. And then it could be a virtual environment if you really know the incantations.
Yeah, yeah. That's probably like, when we did the release in February, we tried to steer pretty closely to the way pip behaves to make it easy for people. But we did pick a few battles where we wanted to intentionally diverge. And this was one of the bigger ones, which is UV by default requires a virtual environment. So if you try and UV pip install and we can't find a virtual environment in the current directory or an active virtual environment, we'll throw an error. And you can opt out of that by passing a system flag. But unlike pip, right, it's opt out. So you have to, by default, it uses a virtual environment, and you can escape from that if you want to intentionally. So we're trying to, like with these APIs too, like these are all virtual environment. Well, the tool stuff, it is, but in a different way. Like UV run, UV lock, UV sync, these all create a virtual environment in the project directory where the project is defined by a PyProject toml. So if you run UV run in that directory, it will look at the dependencies, resolve them, create a lock file, create a virtual environment, install their locked versions into the virtual environment, run the command. And it does that every time, but it's so fast that hopefully so fast that we can do it. So like if the dependencies haven't changed, it will still make sure that everything's up to date. So if you just use UV run, we try and keep the whole environment in sync for you, and you don't have to think about how do I manage my environment? How do I activate it? How do I install stuff? But we're pretty pro virtual environment. And one thing I want to do, and it's sometimes hard to hold these lines because you have users who come to you and want something really different. And it can be hard not to say yes to a lot of the things that users want. But some lines, I think we have to hold because if we concede on them, sorry, I'm making it sound like a battle, but if we concede on them, it just limits the things we can do in the future. Like if we make things too flexible, it limits some of the possibilities of what we can do in the future. And like one thing that I kind of want to change the perception around is, like I think virtual environments are like they're here to stay, really, and so we like embrace them. But I want to change some of how people like think about virtual environments. In particular, I want to change this whole idea of like activating a virtual environment. Like I want it to feel more like node modules, which people don't necessarily think, highly of node modules. Like I think when people think of node modules, they think of a huge node modules folder with like a ton of bloat. But the idea there is like when you're in a project, you just sort of run commands and all the packages just get installed there, and it just runs in the correct environment with the correct dependencies. And that's actually what I kind of want. That's actually what I want Python to feel like is, there's a virtual environment, but it's actually just kind of like the directories of, it's kind of just like full of packages, full of your dependencies. And you just use the right one at the right points in time. So that's part of the shift that I want us to move towards a little bit. And it's part of why we're very virtual environment first and why we put the virtual environment right in the project in a specific known place, because we want to get away a little bit from this idea of where's the environment? How do I activate it? Do I have the wrong one activated? I want it to feel a little bit more like it is just sort of native to how the project works.
If you're in the context of that thing, then it just uses the right one.
Yeah.
Do you have intentions to do something? I can't remember the PEP, but something to the effect where if you're in a directory and there's no PyProject toml or virtual environment, but if you went up one or two that were both, would it fall to that one, or would it just go, we don't know?
We do that with UV run. So with UV run, we sort of find the root of the project. So we'll look up at parent directories. But we don't, but if you just run Python blah, blah, blah. Obviously we don't hook into anything there. And so, like with a lot of other things, like with UV run, UV lock, UV sync, like we create a virtual environment. If you use our commands, it kind of just like everything just works. But you can also just like activate the virtual environment and like do whatever you want, because we're kind of trying to embrace the fact that virtual environments are like everyone knows, not everyone knows how to use them, but like people are familiar with them. Editors and tooling like revolve around them, right?
Yes.
So things that try to eject from virtual environments tend to cause a lot of problems for editors and workflows. So part of embracing virtual environments, I think, again, is like meeting the ecosystem where it is a little bit and being like, okay, the fact that we use virtual environments and they're just like in your project means that you don't need like a special like editor integration to use UV. Like, like PyCharm will just like let you use that virtual environment. It's just a normal virtual environment from this perspective. So that's part of what we're trying to do is like build things that just work for people, and try and embrace, the standards and the conventions while also, maybe influencing or changing parts of them that we think could be improved or could be made more user-friendly.
Yeah. I don't know why I didn't book you for a 2.5 hour podcast, because that's what we're going to need. So Vincent from Calm Code says UV Run is such a game changer. He may work on a Jupyter runner for that this week. Feels like such a game changer, which is awesome.
Cool. Yeah, there's a lot of cool ideas too around this sort of, sorry, go ahead.
Well, I was going to say, with that in mind, let's dive into this whole project management stuff here. Right? Like this is, I think this is one of the three big pieces of functionality that comes. So, and you've been talking about this sort of some of the features like UV Run and so on, but let's talk through like, suppose I want to create a new project. I want to create a project. I don't have the Python installed. It's a new project. I want to create a pyproject.toml, but I don't remember the format for that.
Yep.
Let's go. How's that work?
Yeah. So we have like a series of commands that kind of manage the project lifecycle for you. So you can run UV init to create a new project. And it has a couple flags based on whether you want to build like a library or a command line application, whether you want it to be structured as like a Python package or just kind of, maybe it's just an application that you're running on your machine. But UV init will create the project. You can then run UV add Flask, UV add Fast API, whatever, to add dependencies. And when you run UV add, we'll automatically generate the lock file and sync the dependencies to your system. So we do have commands like UV lock to generate the lock file and UV sync to download the correct dependencies into your environment. But you can also just kind of use these lifecycle commands, and UV will make sure that everything's in the right state as you go. So you can run UV add, UV run. If you do UV run and then Python blah blah blah, it's what happens behind the scenes is we resolve the dependencies, we make sure the environment's up to date, and then we run that command in the environment. So the whole life cycle of working with your project can be managed through UV init, UV add, UV remove, UV run. There's a lot that goes into that, and there's also a lot of kind of powerful features built in here too. Like when you run UV run, it accepts a flag --with. So you can do UV run --with and put a dependency there. And it will basically just download that, put it in an ephemeral virtual environment and make it available for the command. So you can just pull in one-off dependencies as you need to run things. Like I never actually think about activating environments anymore. Like most of the time when I'm running Python commands to run one-off tooling, I'm running, UV run --with requirements, and I give it a requirements file, and then I pass the name of the file I want to run, and like it just like builds the thing you need and runs the command, then throws it away. And because you have, again, we were talking at the beginning of this episode about how like really fast tools change the ergonomics. Like part of what we're trying to build here is like if we have this packaging system that's really fast, especially for like repeated operations, like I need to keep pulling in. I've downloaded this package before. I need to download it again, use it for this one command. Like we can just like throw away virtual environments and create new virtual environments, in milliseconds. So
if this was a Python -m venv sort of install, it would be way too much overhead. Yeah.
And so, we can just like, even like bunch of dependencies, like if they've been installed on your machine already, it's really, really fast just to pull these things together, use them, and throw them away. So there's just a lot. There's a lot of things that we can do, and I think even like looking forward to the future, there's a lot of things we can do because we have this like performance foundation. Like, I'm thinking about what if you want to test code on like a bunch of different Python versions.
Yeah.
And maybe you don't want to like have to keep destroying and recreating your virtual environment or something like that. Like there's just a whole lot of stuff that we can build that would be really hard to imagine if you didn't have a really fast tool.
Yeah. It definitely changes what's possible. Tushar out there put out an example that is very near and dear to my heart. You know what would be great? If UV could build standalone binaries and embed Python into them.
Yeah.
And
that's an interesting space. It's not something we've built anything around, but yeah, I know it's being described there. Yeah.
I think what I've seen most of the things do is they'll do something like zip up a virtual environment or site packages or something, and then put that in a binary, and then when you run it, it'll spit that out, or maybe do a memory mapped sort of magic to try to map into that and unzip it into memory, or all sorts of weirdness. And I think really for this to be easy, somewhere along the way, I could be wrong, not a core developer, but I feel like Python's import behavior needs to be able to import from an embedded resource in a compiled binary rather than stick in a binary and have the binary do like weird things where it fakes out the path. Because there's always like something that falls apart. But if it pip itself like say, okay, we can import from a memory stream and not just from file system, then these things would be like, oh, well, if that's the case, here's how you just embed those and off it goes. It'd be more like Go, where it's like, here's your one thing, you run it. You know what I mean?
Yeah. There's definitely interesting stuff to explore there. And there's some interesting tools that exist already to try to facilitate some of those things. It's also we've invested time in yet, though.
Yeah. All right. Well,
yeah, I was thinking PyApp is similar. Yeah.
Yeah, PyApp is definitely. I've used PyApp before. Actually, I have an app running on my system right now. It's in a little menu bar thing that's a PyApp app, and it works well. It does work well.
Yep.
Okay.
So the project API is kind of like, if you've used like Poetry or PDM, like these tools that are oriented around working on a project. And you have a PyProject TOML that defines your dependencies, and you might have some sort of structure. It's based around that kind of workflow of working on a project, which that's like one way that people work with Python. But there's a lot of ways. There's a lot of things that people do with Python, which is why we have a couple different APIs, right? So we also have this tool API, like UV tool install, UV tool run, which we've aliased to UVX. These are for running.
This is interesting.
Yeah. These are for running like not one-off commands, but like things that you want installed globally. So like you might want rough installed globally on your machine so you can run it on a bunch of different projects. We call those like tools, and you install them. It's similar if you've used pipx before. We install them into dedicated environments and put them on your path. And there's a lot of really cool stuff here. Like I now use UVX all the time when I want to run things. So I'll do like UVX rough check, and that translates to UV tool run rough, run the check command. And behind the scenes, what it does is it finds the latest version of rough. It creates an environment with that version, and then it runs the command using the rough binary in there. And there's really no overhead to that if you're kind of running it repeatedly. So this is oriented around like a different way of working with Python, where you have these tools that you need to run on your machine and you use them for different things. So we have like the project interface for working on a project, and then we have the tool interface for running Python, command line tools.
Yeah. So UVX run, well, UVX is the run version. Yeah. You've also got the install. I have some thoughts on when I might do one or the other, but the UV tool install seems like something you might want to run and have around and have autocomplete in your shell. So I could type RU tab and get rough, or I could
Yeah.
UV tool
I think for things
install,
you're going to run
whatever.
repeatedly, it makes a lot of sense to install them. Also, if you have like if you ran UV tool install rough and then you ran like UVX rough, we would use the installed version. So if you already have the tool installed, we'll still pull the installed version, assuming it's compatible with the version request that you made. I generally like UV tool install things that I'm going to run, multiple times. The other really nice thing about UV tool install is we have UV tool upgrade. So you can do like UV tool upgrade -- all, and we'll upgrade all the installed tools. So you don't have to think about like which tools do I have installed, like what versions are they at? Are they out of date?
I love it.
It kind of gives you a way to manage all the Python tools that you're using at a kind of global level. We have a lot of commands like in our docs. We have a lot of like automation tooling built around Python, like, Rough and UV are written in Rust, but a lot of our like documentation tooling, like we have a lot of scripting in Python. And all of our docs now in the doc string at the top have like the UVX command that you run to like run the script.
Nice.
And so I just like copy that and paste that, and then the script just runs with all of its dependencies. So it's like, it's just super, it's just very, very convenient, I think. Like all these APIs and the way they come together. There's a lot, I know it's a lot of different stuff. And that was actually my biggest fear with this release was it's hard to succinctly explain what this release is. Because it's a lot of different things. And it's not like when we released UV in February. When we released UV in February, it's like, this is a new tool. If you know pip, succinct way, like what we're doing. And in this release, it's actually like a lot of different stuff that comes together to tell what I think is a very coherent story, but it's hard to succinctly explain exactly what we did. And I was very like the response to it. I was really heartened, to see that people were like getting it, and they were getting different parts of it. Like different parts of it were speaking to different people, because I actually think different parts of it are like relevant to different ways that people work with Python. So a lot of people were excited about, the lock files, the UV run. A lot of people were excited about the fact that we have this like scripting API. So you can like have these standalone scripts where the dependencies are embedded in them. And if you do UV run that script, we just resolve the dependencies, download them and run the command with those dependencies available, run the script with those dependencies available. So you can have these like hermetic Python scripts. We had the Python install API. So there were just different things that were resonating with people, which I think is what made me happiest in the response to it.
Did you read, I'm sure you read Armin's Rye and UV, August is harvest season for Python packaging?
Yeah.
Yeah, that's a pretty positive take and a pretty wide-ranging recommendation there. It's pretty interesting.
Yeah, the relationship with Rye is something we get a lot of questions about. I think like when we took over Rye, the goal was always like, we want to build UV up to be a suitable replacement that people can migrate from Rye to UV. And we're getting further along that path, but there's still like things we're missing. We don't plan on like deprecating Rye anytime soon, but all of our like new feature development is really happening in UV. And Rye, it's mostly like bug fixes, like keeping things up to date. Rye has actually benefited a lot from UV because it uses UV under the hood. So like Rye has just gotten like there's new features, it's gotten faster. But our goal is really to like find the things that are missing from Rye and make sure we can support them in UV.
Yeah. Last one we've got to cover here is Yevgeny points out single file scripts with dependencies. That's the last one, the script execution. So
yeah,
one of the huge problems is one of the reasons I think Tushar was suggesting it, and I'm also really excited about it, is if you could bundle your code into an application, one of the benefits is you don't have to have a conversation with everyone that runs it on how to do virtual environments, how to do package management, all this kind of stuff. You just say run, click it or whatever. And somewhat short of that is I want to give you just a script of some sort.
Yep.
And just say run this, right? Here's the script. You have an example.py to run that. But if you put some sort of magical incantation, which it's backed by a PEP, to say what it actually requires, then UV dash dash script something, it'll just see that and go, okay, or UV run rather, it'll see that, install the pieces ephemerally, right, and run. That's pretty cool.
Yeah,
Hopefully
exactly.
about
So
that as our kind of our last thing before we run out of
it's
time.
really
Right?
so this is backed by a PEP. I think it's 723 if I recall correctly. So this is like a standardized. This syntax at the top of the file is standardized. Might not be mentioned
somewhere. Yeah. There's a bunch of PEP conversations, but not the one. Not around.
Yeah, we sometimes try and like shy away from talking about user-facing features in terms of PEPs. Just because
there you go, 723. That's it.
Yeah. Okay. Well, there it is. But anyway, so the idea here is like you can declare the dependencies for the script right in the script, and then when you do UV run that script, we read that dependency data and we run the script in an environment with those dependencies. The other, I think, really cool piece here is I talked before about UV add. So if you're in a project with a PyProject TOML, you can do like UV add fast API or whatever. But you can also do that for scripts. So if you look for like UV add dash script. So you referred to this like magical incantation at the top. We will actually like create that for you. So if you do UV add dash script and then the script name and the dependencies, like we'll actually just like put that stuff in there for you. So you don't actually have to like remember how to do that. Like you can just do UV run dash script and we will actually like populate that field. So you can create a script, you can manage the dependencies in it with UV, you can run it. This is like super useful. There's some interesting conversations happening now too around like, what if we want to have a lock file for these? Because it's a little bit different, right? This is the list of dependencies. It's not the list of resolved versions. So if you wanted to have like full reproducibility, you probably want a lock file,
and
which is interesting.
Not just these things versions, but they're the transitive closure of all the dependencies.
Correct.
True lock file.
Everything they depend on. So we do that for projects. Like if you do UV lock in a project, we create this lock file that's all the transitive dependencies. It locks the exact URLs, the hashes, the versions, everything. We don't do that right now for scripts just because there isn't really a place to put it. But we're kind of thinking about.
Have you considered the Windows registry? I mean, you could always just like integrate that and import that over to Mac and Linux. That'd be fine.
Yeah, just put everything in the Windows registry.
That's a winning idea. I
the
totally
lock
get
stuff
it.
too. The other thing that's interesting too is like the notebooks. Like people are thinking about how can we add this kind of functionality to notebooks, and being able to declare the dependencies for a notebook right in the notebook, being able to lock them too. There's a lot of cool stuff that we can build now that we have all these primitives connected.
Yeah, for sure. I mean, you could do something like take a hash of the file and then use that hash as the name, and as long as the file doesn't change, it'll run the same. I don't know, but yeah. I'll leave that to y'all. So I think, we didn't even talk about the speed for some of these things, and there's a whole lot of stuff here, but
there's a lot of good stories to tell about how we made some of these things, the problems we had to solve to like build some of the stuff, but they'll make for, if I dream they'll make for good blog posts, in reality, they'll probably make for good Twitter threads.
Absolutely. All right. Well, Charlie, thanks for being here. Maybe give us final thoughts and words for folks who are interested in this new layer of UV.
Yeah, I think like this release is really different from the previous release, in part because we designed and built a lot of stuff that's pretty new for people and also requires people to change their workflows in a lot of cases. Like the previous release, it was like, this is a lot like pip, so kind of just drop it in. And now it's like, here's a bunch of ways to use these tools. If you work, it does require you to work a certain way and kind of think a certain way, but we think it's really powerful. And that's all stuff we're like kind of trying to figure out, right? So we're very eager for, I'm sure all this stuff will change. And I'm just eager for like every release, I'm just excited to have it out, have people testing it, have people using it so we can get feedback. And so, would love for you to try it out. I'd love even more for you to come file issues about the things that don't work so we can make it better and better. But I think we have a really cool foundation here. We can build a lot of things that hopefully make working with Python a lot, a lot easier, in the sense that the tools kind of get out of your way rather than getting in your way. So yeah, that'll be our focus for the next while, is seeing how people are using this stuff and seeing where we can make it better.
Well, I think it's pretty awesome what y'all are up to. Big fan of UV, so happy to see the project.
Thank you. I
Progress
appreciate
here,
it.
and always happy to have you on. So, thanks.
Thank you.
Yeah. See you later.
Bye.